Good morning, fifth graders, and welcome to Math Today, and welcome to a brand new quarter. So on your screen, you can see some instructions. Because we are in a new quarter, we will also have a new Math Google Classroom to keep all of our work for this quarter organized. So what I want you to do is I want you to click on Google Classroom. I want you to click the plus sign in the upper right corner, and I think you need to click join class. I'm not quite sure. And then I need you to enter this code, and I'm going to read the code to you, and then I want you to pause the video, and I want you to go and enter this into Google Classroom. The code is LHRT 72Q. So click pause, take this code, enter into the Google Classroom so that you have a brand new place, because that's where your assignment is going to be stored. So until you are in that Google Classroom, you won't be able to see today's assignment. And then when you come back, just unpause the video. All right, moving on to some announcements. This Friday will be our next math review, October 30th at 9:30 a.m. It will be a Zoom review, and I will be going over all of the things that we talk about this week in math. We're starting chapter 3, which is all about decimals, so we will discuss all of the lessons that we go through this week. The Zoom link for the review will be included in your Friday to-do list in the Start Here Every Day Google Classroom. And that Google Classroom has not changed. It does not have a new code. It will stay the same throughout the year. So that's where you will go for your Zoom link. It will not be emailed to you. So make sure that on Friday that you go there to get your list of things to do and that you click on the Zoom link to join the review. All right, today we're starting chapter 3. So our lesson will be lesson 3.1, title Thousandths. We're going to begin on page 153. So go ahead and open up your math books and work alongside with me today. Our objective is to be able to understand how to create a decimal number from a picture and make any number with a decimal 10 times as much, and also to find 1/10 of the number with a decimal. So let's go ahead and start. On page 153, now I have this chart here. You do not have access to it, but I just pulled it off the internet and I'm going to use it today to show you that decimals are a little bit different than whole numbers. Looking at your chart, we're so used to these place values starting with the ones and going all the way up into the millions. But we're going to go and insert a decimal point today, and that decimal point separates all of our whole numbers, which are to the left, and all of our decimal numbers to the right. Decimals are parts of numbers. They're not whole numbers, they're parts. So this decimal is really important because it separates all the whole pieces to the left from all the parts of pieces, parts of whole numbers over here to the right. So our decimals work just the same as they do with whole numbers. It's still based in a base 10 system. So as you go to the left in a whole number, it gets bigger by 10 times. And as you go to the right in decimals, the number gets 1/10 of its value. And still the same is true when you go to the left, it makes it 10 times bigger, 10 times as much. So the first part of our objective is to be able to look at a picture and to be able to write the decimal shown by the shaded parts of each model. So I'm going to connect this model to this place value chart. When we talk about whole numbers, we're talking about the whole square, the whole big one, the whole enchilada. That's where the ones would go. This is one whole square. But if you'll notice, not all of it is shaded in. There are parts that are shaded and there are parts that are not. So I've taken this whole number and I've cut it up into pieces. That's where the decimals come in. Decimals are pieces of whole numbers. So I cannot say that I have a whole square shaded in. So I have 0 ones shaded in. But you'll notice that this big square is split or cut into 10 columns. And each of these columns represent a tenth of my whole square. So this is where the tenths come in. Every time I have a whole entire column shaded, that counts as a tenth. So I'm going to count how many tenths I have that are completely shaded from top to bottom. So I have this column, column 1, 2 columns, 3 columns, 4 columns, 5 columns, and 6 columns. So I have 6 tenths that are completely shaded because each of these has 10 pieces that are shaded from top to bottom. Now the next thing I'm going to look at is how many hundredths I have. This is where I take this partial column right here. Not all of it is shaded, so it can't make a tenth. And I'm going to take this column and I'm going to cut it into 10 equal pieces. And that's what makes the individual squares, and they're called hundredths because in this entire square I have 100 smaller squares. So that's where the term hundredths comes from. And here I'm just going to count the ones that are blue. So I have 1, 2, 3, 4, 5, 6. So I have hundredths. And now this piece right here that's showcased over here to the right, I'm taking one of these pieces, but I'm going to chop it into even tinier pieces. So it's kind of been enlarged like a microscope so you can see what's happening. If you take just this one square right here, which represents thousandths, if you take it over here and cut it into 10 equal pieces, so you'll see 10 pieces here, and if I shade in a part of them, 1, 2, 3, 4, 5, that makes up my thousandths. So I have now described all the parts that are shaded. And I'm going to take this answer that I have here and I'm going to move it down here. I have 0 whole squares. I have 6 columns. I have 6 extra squares that were not able to be a full column, a tenth. And I have this little guy that was split into 10 more pieces, and I only have 5 of them. I have half of them. So I have now written a decimal that represents this picture, which is 665 thousandths, because this last digit falls into the thousandths place. So let's continue on, same page, but let's look at number 2. So again, if this big square here represents the number 1, and you can see that all of it is not shaded in. So I have 0 ones. I have 0 whole squares that are shaded in. But then if I look at the next place value, which is tenths, so I have no holes, but I have this decimal point that's going to separate. Now I'm cutting into pieces. So now if I take this big square and I cut it into 10 pieces. Every piece is a column. Oops. 6, 7, 8, 9, 10. So my 10 columns represent the tenths place. And I have 1 whole tenth shaded in, 2 whole tenths, 3 whole tenths, and this is where my whole column stops. So I have 3 whole columns that are shaded in. Now this 4th column has some that are shaded in, but 1 that is not. So if I count the ones that are shaded in, 1, 2, 3, 4, 5, 6, 7, 8, 9, that would be 9/100ths. And then if I take this guy right here, this next square, and I cut it into 10 more pieces and then count what I've shaded in, 1, 2, 3, 4, 5, 6, 7, 8, that would be the thousandths. So I can represent this model by saying 0 and 398, and these are thousandths with that THS on the end, because thousands right here are not the same. These are whole thousands. These are pieces of thousands, so they become thousandths. All right, same page, but let's look at number 3, doing the same thing, taking this model and representing it with a decimal number. So first of all, as I look at the entire square, I notice that the whole thing is not shaded in, so I have 0 ones. My decimal point will separate my wholes from my pieces. And if I look at the tenths, which are the columns from top to bottom, and there are 10 of them in this whole square, I see that only 1 of them is shaded in. So I'm going to include 1/10. In the second column, there are some that are shaded. 1, 2, 3, 4, 5, 6, 7, 8. So that will be 8/100ths. And then if I take this square, just this one right here, and I cut it into 10 more pieces, and I color in 1, that will be 1/1000th. And then I take this number and fill it in down here. So this picture represents 0 and 181 thousandths, because this digit, this last digit, is in the thousandths place. Now if I were to take this piece right here, and if I were to take and cut this piece into 10 smaller pieces, then I would create the next place value, which is 10 thousandths. But in 5th grade, we only work with numbers up to the thousandths place. So these are the place values you need to be familiar with: tenths, hundredths, thousandths. All right, now that we know how to represent a model with a decimal number, now we're going to take some decimals. And the second part of our objective today was to be able to take said decimal and make it 10 times as much, and then take the decimal again and make 1/10 of it. Now this is very similar to what we did in chapter 1 in lesson 1.1, where we took whole numbers and we made them 10 times as much. And we also took whole numbers and we took 1/10 of that number. But with decimals, and I tried to teach this also as well when we did whole numbers, that when you're making a number 10 times as much and taking 1/10 of, you're just switching a decimal. You're switching places with a decimal. So when you take 0.2, or 0 and 2/10, we're not just going to add a 0 onto the end like we did with whole numbers. This is an actual decimal change. Because whenever you move the decimal, you have to move it either to the right or to the left. And as you move to the right, you're always going to make a number 10 times as much. When you move the decimal one place value to the left, you're always taking 1/10 of the decimal. So let's make it 10 times as much by moving the decimal one place to the right. And as I do that, I have a new number. And this 0 is no longer needed because we don't need zeros in front of whole numbers. Now remember that this decimal separates wholes from pieces. So this 2 is now a whole number, and this decimal is separating it from the 0 pieces that are left behind. So my new number, 10 times as much, is going to be the whole number 2. Remember, whole numbers have decimals hiding at the end with nothing of value after them. So I can write this number one of two ways. This is acceptable and this is acceptable. If this were a question on an assignment or a quiz or an assessment, either one of these answers would be correct because they are the same in value. Now let's take the same decimal, which is 2/10, but this time I'm going to make it 1/10 of this value. So to do that, I'm going to move the decimal one place to the left. And as the decimal changes, that means that my number is going to actually look like this. Instead of 2/10, I now have 2/100. And in math, we always put the 0 in front. No naked and afraid decimals. Don't want them to be afraid. So we'll put a 0 here to make it feel safe. So 2/100 is 1/10 the value of 2/100. Okay. All right, let's continue on, but pick up our pace a little bit. So if I have this decimal and I want to make it 10 times as much, well, 10 times as much is moving the decimal one place value to the right. And when I do that, instead of the decimal being here, it's over here. So that means I can get rid of this 0, keep this guy, because there's a decimal right here that I don't want to be naked and afraid. And then I have the 7/10. So this is 10 times as much as 7/100. Then if I take and I move the decimal the other way to take 1/10 of it, so I'll move it one place value to the left. Instead of being here, it's now here. And because I have a decimal here, I'm going to put a 0 in front. No naked and afraid decimals. 0/10 and 7/100. This number is now, oh, I'm sorry. I totally got ahead of myself. Can't be equal to each other. If the decimal's over here now, then there are two zeros. 0/10, 0/100, but I have 7/1000. So this number is now 1/10 of what it started at. All right, next one. Let's make it 10 times as much. So I'll move it to the right, one place value. I'll get rid of this 0, keep this guy. And then I'm going to insert a decimal here, and then my 5/10. This number is now 10 times as much. Now if I do the opposite, which is to take 1/10, then I will move the decimal one place value to the left. I'll insert a 0 over here, decimal, right where it is over here. Now I have 0/10, 0/100, and 5/1000. So 5/1000 is 1/10 of 5/100. And then finally, with this decimal number, if I make it 10 times as much, move the decimal one place value to the right. And since the decimal is over here, I am going to get rid of the 0 in front. Now I can just leave it just like this as 4 because there's nothing after the decimal, and I make the decimal hide at the end of the whole number. Or if I really like that decimal, I'll place it, but I need to place a 0 after. Remember, no naked and afraid decimals. They don't want to hang out and be naked. So they're either hiding at the end of a whole number, they're invisible, or they like to be sandwiched between two numbers to feel safe. So you can include it as just 4 or 4.0 or 4 and 0/10. And then if I do the opposite, I take a tenth of this number, then I'm going to move the decimal to the left one place value. So that's going to turn my number into, add a 0, include the decimal point, no naked and afraid decimals, 0/10, 400ths. And that's how I make 10 times as much, or 1/10 of. All right, the next skill is a little bit trickier. So I saved it towards the end because you need to complete the sentence, and you kind of need to think about this skill, kind of like what we just did here, but you kind of need to think about it in reverse. And we looked at some of these statements in chapter 1 as well. So let's write down exactly what this phrase says. This phrase says that 6/10, and the word is in math is an equal sign, 10 times as much as a number I don't know. I need to figure that out. I need to use my algebra skills to figure it out. So if I'm looking for this number, and I know that whatever this number is, if I make it 10 times bigger, it's going to equal 6/10. So since I'm searching for the beginning number of what was made 10 times bigger, I'm going to do the opposite of making it 10 times bigger. And the opposite of making it 10 times bigger would be to take a tenth of this number. So if I start with the number I know and take a tenth of it, which is one place value move to the left, put a 0 in front, my new number is actually 0 and 6/100ths. So now I know the number that I started with. This number is 10 times as much as 6/100ths because 6 is in the 100th spot. All right, let's look at number 7. So if I have this number, and I'm going to write exactly what this math statement says. If 8, and this is tenths, hundredths, thousandths, 8 thousandths is 1/10, and in math when we use the word of, we're using the multiplication sign, of a number I don't know yet. But I'm going to use my math skills to figure it out. So if I were to take this number and make it 1/10, so I take a tenth of it, I'm going to end up with this number. So I'm going to do the opposite of a tenth because I'm on the other side of the equal sign. And the opposite of taking a tenth is to find a number that's 10 times as much. So if I take this number right here, and instead of taking a tenth of it, if I make it 10 times bigger, I will know the number that belongs in this box. So to make it 10 times bigger, I move the decimal to the right one place value. So the decimal has moved. It's no longer here, so I can cross off this stuff in front, and I'm left with 0 and 8/100ths. No tenths, but 8/100ths. So this is my starting number, and this is the number that completes the statement. All right, let's take what we've learned so far and let's kind of apply this to a real life situation. And I'm going to change pages, so please move over to page 155 and go down to the problem solving section. And we're going to look at this real life example of US coins and their diameters from side to side of the coin in inches. So if you had a coin, if you're finding the diameter, you're finding out the length from side to side of the coin. And here are some diameters that we already know for the penny, for the nickel, the quarter, and the $half. So these are all those measurements. And remember, anything before the decimal is in the ones place, and anything after is in the tenths, the hundredths, or the thousandths place. So let's look at number 9 and read it together. The diameter of a dime is 705 thousandths of an inch. That means it's less than an inch. It's not a full inch. Complete the table by recording the diameter of a dime. So I'm going to take out only the pieces that I need right now. So I'm looking to complete the table, but I just want this piece, 705 thousandths. And because I don't have the word and, the decimal always stands for the word and. I did not have the word and, so I know that there are no wholes here. I have no ones. I don't have any whole inches here. But I do know that I have 705 thousandths of an inch. So that means I have 7/10ths, I have 0/100ths, and 5 thousandths. So I'm going to take this number and transfer it to the table. All right, let's look at number 10. What is the value of the 5 in the diameter of a $half? Now, since this is my only sentence, it's obvious this is what I'm searching for. So I am searching for the value of the 5, and I need the $half measurement. So if I come over here to the $half and focus on this amount, and I'm going to erase what I used this chart for number 9, and I'm going to insert this number, 1 and 205 thousandths. So we're focusing on this guy, the 5. Now remember, these are the ones, these are the tenths, these are the hundredths, and these are the thousandths. So we can see that the 5 is in the thousandths place. Now when we find the value of a number, we keep the digit where it is, and everything to the left turns to a 0. We did this in whole numbers, but our whole numbers were over here, so we brought down the digit and we turned everything to the right to zeros, and the opposite is true for decimals. So we'll keep the digit we want, and we'll turn the rest of them to the left into zeros. So that means that the value of the 5 in this number right here is worth 5 thousandths, and that's how you would write the value. All right, be my partner for just a moment. And on the same page, page 155, if you will come up to number 2, let's just do a quick review of all the things that we talked about today, and I'm going to pick up my pace a little bit. So here's a model, and I want to be able to put this into a decimal answer over here. I have a whole square, but not all of it is shaded in, so I'll represent that with 0. And now I'm going to look at the pieces that I made. In this whole square, I have 10 columns of pieces. So how many full columns? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'll put a 9 in the 10th place. I have the 10th column, but not all of it is filled in. So I'm going to count those hundredths that are there. 1, 2, 3, 4, 5, 6, 7. And then if I take this little bad guy right here and I cut him into 10 more pieces to create thousandths, and one of them is shaded in, then I will put 1 in the thousandths place. So I have 0 and or just 971 thousandths. And those are tiny pieces. Okay, making a decimal 10 times as much. All I'm going to do is move it to the right, 1 place value. Take off the 0, I'm left with 1. I can leave it like that, or I can put the decimal back and a 0 at the end to make this decimal feel comfortable. To make it 1/10 of, you are going to take the decimal and move it 1 place value to the left. So that decimal's not afraid and hanging out by itself. I inserted a 0 at the beginning. So 1/10 is 1/100th of 1/10. All right, next number. If I make this 10 times as much, I'm going to move the decimal 1 place value to the right. I'm going to get rid of this guy, so I'm left with 9/10. And then if I do the opposite, which is to take a 10th, I'm going to move the decimal 1 place value to the left and insert a 0. So now my answer looks like this, which would be read as 9 thousandths. Okay, these tricky statements. So I'm going to just write what they are. 4/10 is 10 times as much as a number I don't know yet. So instead of making it 10 times bigger, I'm going to do the opposite, and I'm going to make 4/10 1/10 of its value. So I'll move the decimal to the left, put a 0 in front, and this number, 4 thousandths, completes the statement. And then for our last question, if I take this number and complete the statement, is an equal sign, 1/10 of a number I don't know yet. So instead of taking a 10th of the number, I'm going to do the opposite. And what is that? I'm going to make it 10 times as much. So if I take this number and make it 10 times as much by moving the decimal 1 place to the right, take off this 0, and I'm left with 3/100ths. 3/100ths, this number here, is 1/10 of 3/100ths. All right, guys, let's move on to independent work. This is where you need to get out some scratch paper because you're going to need to do some decimal changing around. And you're going to go to your math second quarter Google Classroom. Find the topic Chapter 3 Go Math. Complete this assignment. You must fill out the Google form to get credit for this assignment. Click Submit when you're done. Click Mark as Done. And then you shouldn't have any math assignments to finish up because this is the first day of the brand new quarter. And if you want to do some optional minutes in ST Math, you are welcome to do so. Contact me if you have any questions. I'll see you tomorrow.